In this reaction, the reactants are hydrogen peroxide and dish soap, and the potassium iodide serves as a catalyst. We're going to be doing a trial for our elephant toothpaste. The first thing you want to do is put goggles on in case the chemicals splash into your eyes. They could damage your eyes, so you want to make sure you have goggles on. And then first thing we're going to do is we're going to add the hydrogen peroxide to the graduated cylinder. It should be in a 3 to 1.5 ratio with the potassium iodide. Even though it is a catalyst, it's very important to the reaction because it actually creates the visual effect that you're looking for, which is kind of explosive and spontaneous. And then the second thing we're going to do is we're going to measure out the potassium iodide. You want to make sure that you zero the scale first with the weigh vote, so you make sure you only get the weight of the potassium iodide. Okay, so now that this is zeroed,
I think it actually is. Is there really not? There should be.
okay, so then you have to add just a little more to make sure you get to the proper ratio.
Perfect.
So then you have to add the dish soap, which is the other reactant with the hydrogen peroxide. So for the dish soap, you just want to do like about half a spatula. You don't want to add too much because if you add too much dish soap to it, then it won't go as fast as it's supposed to. Next, you want to add the food coloring. We also added food coloring just to add some color to it and make it look nicer, but we found that when you add the food coloring, it actually slows the reaction down and creates like a dissolving kind of effect as opposed to like the pop that you're looking for. So when we did research on this, we found that there was the compound propylene glycol contained in the food coloring that we used, and the propylene glycol actually served as an inhibitor. This is because when placed in a reaction where there's also water present, and water is one of the products from the initial reaction, it absorbs the water and creates a dehydration reaction. So this worked actually over the catalyst, and the catalyst had no effect on it. So then as soon as the water was produced, it was quickly absorbed, so it couldn't like pop out like we expected it to. So we had to change like the ratio we had already planned. We had already planned to have the hydrogen peroxide and the potassium iodide in a 5-to-1 ratio, but because of the food coloring acting as an inhibitor, we couldn't have this ratio anymore just because like it wouldn't work and it would just have a very slow reaction that is not what we were looking for at all. So then we finally tested like several different ones and it kind of kept happening. So our final one that we tested was 3 milliliters of hydrogen peroxide to 1.5 grams of potassium iodide. And this is what ended up working really well, and we actually used this in our final experiment, which you'll see later in this video. It also like forms propylene oxide is one of the products between the propylene glycol reaction, and that's what ends up dissolving the water.
However, it is
An inhibitor.
an inhibitor.
Yeah.
So we did change our ratios to make it suitable for the food coloring because it would slow it down.
We initially used a 5-to-1 ratio, and now it's a 3 to 1.5. Okay, the final step is to add potassium iodide.
And watch the magic happen.
There you go.
We're measuring out hydrogen peroxide. This is actually one of our failed trials, but it was still pretty cool. So we're measuring out our hydrogen peroxide. We're using the 12% hydrogen peroxide, so we're using more of that instead of the actual ratio because we had 33%. So that goes in. And in this failed trial, we did not include the dish soap. So let's measure out potassium iodide. And now I'm gonna add the food coloring. this is what's gonna happen.
What? This is the initial trial where we forgot to add the dish soap.
We also found that the reaction is an exothermic reaction, and it produces not only the foam that you see in the reaction, but heat. So in the actual reaction that we performed on the grass outside, it actually burned the patch of grass because it was so hot after the reaction occurred. And we also had a lot of trouble carrying the test tube back in just because it was so hot on the outside and it was steaming up and everything. So that's produces a lot of heat because that's when we used the biggest ratio. We didn't see that so much when we did our smaller tests because it was just not as much, and so there wasn't as much heat that was produced. But therefore, once it became a very large scale, then there was so much heat produced that there was just an abundance of just hot temperatures, and we couldn't even touch it really to get it back inside. And then the final thing that I want to talk about in this is why the iodide works as a catalyst. So basically what happens is it extracts the oxygen from the foam bubbles that are created, and although this would happen just normally because of the air on atmosphere, it would take hours or even days to complete the reaction without the iodide. And the iodide is actually what causes it to shoot up because of that. It greatly increases the fluid pressure underneath it because the oxygen is being extracted so quickly and causes it to just shoot up out of the tube into the big foamy thing that we all saw when we performed.
That was pretty cool, actually. It didn't shoot up.
Yeah, I thought it would shoot up because
I thought it would.
Yeah.
But it